Hello, in this video we're going to talk about the application of linear programming problem, which is real world problem. So here is the example. A catering company is to make a lunch for business meeting. So usually in this type of question, it would be easier to make a chart. We've been doing that for lots of times in the previous videos. So now let's make a chart together. Okay, it will serve a ham sandwich, light sandwich, and the vegetarian sandwich. So we know that there is going to be three types of sandwich. Let me draw these a little bit taller. It's going to be ham sandwich, light. Hold on, sorry. It's going to be ham sandwich, light ham sandwich, and then veggie sandwich. So for ham sandwich, so they have one serving of vegetables. So we know that for veggie, the ham sandwich contains one serving and 4 slices of ham, and also 1 slice of cheese. Okay, and 2 slices of bread. So for the light sandwich, it contains 2 servings of vegetable, 2 servings of ham, and 1 slice of cheese and 2 slices of bread. For vegetarian sandwich, they contains 3 servings of vegetable and 2 slices of ham and 2 slices of bread. So since they're vegetarian, veggie sandwich, they don't serve any ham. And now they tell you that a total of 10 bags of ham are available, and each of them contains 14 slices. So the total number, this is a little bit tricky. We need to do a little bit math about it. So there are 10 bags of ham available, and each one contains 14 slices. So the total number of ham should be 14 times 10, which is 400. Okay, so the next one is totally is going to be 18 loaves of bread are available, and each one contains 14 slices. So we want 18 times 14 for the total number of bread. Let me use a calculator to calculate that. We have 18 times 14. Totally is 252. Let me write this. Alright, so for vegetable, they totally are 200 servings are available. What about cheese? So they have 15 bags of cheese, each with 60 slices. So I use 15 times 60. I have 900 slices of cheese. So here is our chart. The chart will help us to simplify all the work we've done. So now, since we already simplified it, let's move up and see how can we make this chart. Okay. So we know that no matter what we are making, we can make the stuff above what we have, right? So if we have total 200 vegetables, 200 serving vegetables, we cannot make 100 serving of vegetable sandwich. Otherwise, we will not have enough vegetable to make that sandwich. So when we try to set up the problem, we are going to make S number of ham, Y number of light ham, and Z number of veggie sandwich. So the total serving of vegetable we need is going to be what? X plus 2 times Y plus 3Z. It has to be less than or equals to 200. And then we have 4 times X for the ham. How many hams do we need for the ham sandwich? Plus the ham that we need for the light ham sandwich, plus 0 for the veggie, less than 400 slices. And then last is the cheese, for the cheese. So we have what, x plus s plus 2z has to be less than or equals to 900. It seems like we have sufficient of cheese. Okay, for the bread, they are the same. They all require 2 slices of bread. Oh, sorry, this should be y. So these is going to be our subject equations, the subject functions. So what would be our maximize function? We're trying to maximize, if we look back for the question, we're trying to maximize the number of the sandwich. So the maximize P should equals to the number of the ham sandwich plus the number of the light ham sandwich and plus the veggie sandwich. So this is going to be our maximize. And now we can construct a tableau trying to figure out what will be the maximizer and use our simplest method to solve it. So here is the tableau. I'm going to pause the video and just fill it in because we already done in the previous section. We already done enough exercise how to use a simplest method to solve this maximize profit problem. So here I am going to skip all the steps, and I'm going to construct the initial tableau, and maybe you can check the answer with me. So here is the tableau. So the final answer after we calculate that, I'm going to skip all of this because I believe that all of you can do it. So here's the answer. X is going to equals to 100, y equals to 0, and z equals to 26. And the maximum number of sandwiches the company is going to bring is 126. So that means we found that 100 ham sandwiches, and then 26 vegetarian sandwich, and the 0 light sandwich, 0 light ham sandwich should be made to maximize the total number of sandwich. Okay, so now I want to show you another example how to set up the equations. Hey, I'm sorry totally for the blackout because this room, my office room, is the light is sensor, so I haven't been moving for a long time, so that's why it got turned off. Okay, anyway, let's get back to the profit. So we just finished about the profit from the A product. So for B products, our total profit is going to be 30 times each product you make out of B, which is 13 times Y, plus 14 times Z. This is the total profit from the C product. So here is going to be our subject function and the maximize function, which is object function. Okay, so if you use the simplest method to calculate it, so your answer should be, by solving this, you will have X equals to 120, B equals to 13, C equals to 0, and the total profit is going to 13,300. So that means we will maximize our profit at 3,300 by producing 120 item A and 13 item B and no units or no item for item C. So in this chapter, we'll focus on how to set up the problem, because we already learned how to use implicit method in the previous lectures. If you don't remember, please go back and check it out. I'm not going to repeat it here. Here, I'm going to show you the one last examples. So a factory manufactures 3 types of products, A, B, C, and each product requires a certain numbers of hours manufacturing, assembling, and the finished time shown below, along with the total time available and the profit from the production level to maximize the profit. Again, this is a similar problem. We will let the number of product A, I'm going to write it here, let X be the number of item A, and then Y be the number of item B, and then Z be the number of the item C. Okay, so our total hour for manufacturing is 300. So that should be including you manufacture the item A, manufacturing item B, and manufacturing item C. So the first subject function should be, constraint function should be 4x plus 5y plus 2z less than or equals to 300. Please pause the video and try these two by yourself. Okay, so the second one should be 7x plus 4y plus 1z should be less than or equals to 250. Next one is 4x, plus 5y plus z less than or equals to 200. These should be your subject or constraint function. So what will be the maximize function or your object function? Well, we're trying to maximize the profit. So the profit should equals to the profit that you make out of all of the item A, which is 175x, plus the profit from item B, which is 113 times y, plus the profit that you made from item C, which is 14 times z. So here is the setup for our maximize equation. So for this one, if you want to solve it by yourself, you will end up have an optimized solution with a decimal. But however, this is a trick. In real world, you round up or round down. So maybe you will say, hey, this is full too. I should round up. Well, so there's a trick. We always trying to round down when it comes to maximize problem, because we don't want to end up running out of the material that we need. So let's say, even though this is 18.72, if that's your final answer, you're still trying to round down instead of round up. Because we need to, in real world, in a business world problem, we were trying to concern about, hey, if we have enough raw material to produce this product. So this is the trick part. We're always trying to round down. So after round down, the A should equals to 18, B equals to 5, and C is 100. So that means we would use totally enough, have enough manufacturing hours to produce all the assembling and the finish hour to produce all of these products. And after you run down, you need to plug into the new profit, the profit function, to recalculate what will be the actual profit. So I have the actual profit should be 7,840. So I'm going to say this again, why we're doing this. Because in real business, we don't want to run out of the raw material or the hours. So we always want to keep this in a feasible region. Remember what is feasible region, which is bounded by this subject function. So we always try to get the small number instead of the large number. So for this problem, we should have a product we want to make 18 of A product, and then 5 of B product, 5 numbers of B product, and 100 C products. Okay, so that's it for today. Let me know if you have other questions.